Hey everyone, welcome back. It is Thursday night, and I thought I'd do a little short video to get us ready for some stuff I'm going to be experimenting with this weekend. So I mentioned wanting to use some of the timescale analytics functions on some price data. And before I can do that though, I need to actually load up some price data. So in this video, I'm going to show you how to fetch some minute bars from the Alpaca Polygon IO API, which we've used in this channel a bunch of times before. But to make it more interesting this time, I thought I'd use some async functionality of Python. So we're going to use async IO, asyncpg, and aiohtp to fetch a lot of this price data concurrently. So if you've watched the full stack tutorial in the past, when we fetched a price data, we would just say, fetch me the price data for Apple stock. We'd wait, that data would come back, then we'd fetch the data for Amazon stock. We'd wait a while, then it would come back, and it took a while, right? Because we did all of the stocks in the NASDAQ 100, which is only 100 stocks. However, just doing that fetch and waiting for a response, then inserting a bunch of data into the database, and I looped through the data in order and just did a bunch of insert statements. And that actually took a while. It might have even taken like 30 minutes or so. I don't remember the exact benchmark, but I thought we'd explore using async IO in this particular case. One of the commenters who hangs out here, Rich Wheels, often mentions that he's using asyncpg and was able to also fetch data faster using aiohtp. So I thought I'd start using that a little bit more on the channel. But real quick, I wanted to hopefully give a little bit of explanation of what this is, because not everyone programs in this fashion. A lot of times it's just easier to understand your code if you write it synchronously. So async IO lets you write code that runs concurrently, which means many things can be happening simultaneously. You're not blocking and waiting for responses over and over again, or waiting for a function to finish or a line to finish before moving on to the next one. And if you watch the Interactive Brokers API tutorial that I created, I talked a little bit about async programming here, because that kind of way of looking at things it's required in order to use IB in sync effectively. So the example I used in that video was this one that I liked from Miguel Grinberg from this PyCon 2017, and he talked about the idea of a chess exhibition where this champion chess player plays all these guys in the room. And the example, just the current example, if you watched Queen's Gambit here, there's a scene where she plays like 12 different people, so Beth versus 12 players. But you'll notice what she's doing in the room. She's moving from table to table, and she's just making a move, making a move, making a move. And she's able to beat all of these players fairly quickly, even though each of those individual players move very slowly, right? And so you'll see where she quickly checkmates them all. So in a synchronous approach, what Beth would be doing here is she would make a move, she would wait for this other slow player that might take a minute or two to make a move, and then she would move on to the next player, make a move, and then wait for the other player to make a move, and so forth, right? And that's kind of how synchronous requests work, right? You would make a fetch to google.com, you'd wait, fetch to yahoofinance.com, and with price data, right, we're just fetching it from an API repeatedly. And so the idea here is that we can just make a request, and before it completely comes back, right, we can go ahead and make another request. So we just fire off a bunch of them basically in a loop in parallel, and then we don't have to wait on the first one to finish. And the idea is that all of them can come back faster if we don't have to wait for them one at a time. And to illustrate that real quick, let me just write a quick, I'm just going to bust out a quick synchronous program that uses requests. So we've used requests many times, right? Okay, and then I have this list of URLs, so 100 URLs, and I forgot where I got this from. This example is probably somewhere else as well. So there's a list of websites here, and let's pretend these are API requests, and we're just fetching the content of each of those websites, right? And so to do that, I would just import requests, and I'm going to import time so that I can just time how long it takes so you can see the difference in speed. And so this file is called URLs, and I have this variable websites. So I'm just going to say from URLs import websites, and then I'm going to split that list of websites, right? So I'm going to do websites.split. Okay, and so I'm going to split on the carriage return, and then I'm going to say that'll give us a certain number of URLs. So our num URLs equals the length of URLs, and then I'll just say the start time is time.time, so I'm going to start a little timer, timestamp. And I'm going to say for URL in URLs, I'm going to print fetching URL, and I'll make this an F string, and I'll just go URL like that. And then I'll do R equals request.get URL. And so I'm making an HTTP request to fetch each of those URLs, and then I'll do a little end, and I'll do time.time, and then I'm going to do print took this number of seconds to pull this many websites, right? And I'll do end minus start. So I'll do an F string, and I'll do end minus start, and then I'll do num URLs. And if I run that, you'll see it's fetching youtube.com, fetching facebook.com. You know, it's pretty fast, but you see how there's a little bit of pause between fetching each website, and it's not going to go to the next one in this list, right? So it starts at YouTube, Facebook, and it's just going in this order, waiting for one after the other, after the other, after the other. And it is still running. And let's just wait for it to finish. It won't take that long. All right, you can see it did eventually finish, and it took 60 seconds, so 1 minute to pull 100 websites, which, it's not so bad, but I have this asynchronous version here, and let's talk about how that works real quick. So first of all, the libraries we're using, I use requests to do the synchronous version, but I need aiohttp, which is the aiohttp library, which is right here. We're going to be using that. And then I also am going to use asyncpg, which is an asynchronous Postgres database library. So I'm going to be using that instead of asyncpg2, and that lets us basically copy a lot of data and insert a lot of data into Postgres from these responses really quickly as well. So let's quickly break down what an async version of this website fetcher would look like. So at the top here, you see I've imported async.io and aiohttp. I'm importing time so that I can just time how long this is going to take, and I'm importing this list of websites. So in the main body here, I'm just splitting that list of websites so that I have a list of URLs, and I'm using asyncio.run to just kick off this program. And what's happening here is this async coroutine here. So this is not a function, it's a coroutine. So this block of code can have this keyword called await. And what this does is this is using aiohttp's HTTP client to share this connection, and then it's using that connection to fetch a bunch of URLs, right? So I'm saying session.get URL equals URL. And so this block of code is what you would use to fetch a single URL, right? And so what this await does is each time this get is called with a different URL, so it'll get like yahoo.com, then google.com, then baidu.com. But this await, what allows it to do is say, you can go ahead and go on to the next thing, go do something else. I'm still waiting for this response. So await sort of suspends the execution of this here, and then it can go on to the next get. So there's basically a list of 100 calls to get here, right? But all those can run, and it doesn't have to wait for the first one to finish. So they can all just be fired off concurrently, similar to the chess example we have, right? So you're just making a move, making a move, making a move, right? And so async.gather is basically giving a list of, chessboards and saying make a move on each one, but she can just keep going on and on without waiting for this first web request to return. But once it finally does, right, it finally gets a response, and then we print this line saying we successfully got the response. But you'll notice when we actually run this, right, even though it starts with youtube.com, facebook.com, baidu.com, and we have this print statement here, it's not gonna print in the same exact order because one back here might finish first, but they're all gonna eventually get back and print this line of code. And so just to run it real quick, so you see how this looks. So it's saying async.io gather, fire off all of these coroutines concurrently, do this work on each URL, but you don't have to wait on the first one to finish. They're not going to execute sequentially, right? So now let me run that, and then you see how fast that is. I'm going to have it Oh, I didn't even have time to drink my wine because it finished in 2.5 seconds. So it wasn't that all these sites took forever to respond. It's just we were waiting for each one in sequential order when we could just fire off a bunch of requests and have them all come back concurrently. So as you can see here, understanding this approach here could allow you to optimize your programs and fetch data much faster. Not only can we fetch a bunch of web requests much faster, we can also write to our database much faster as well. And that's why I'm going to also show you asyncpg. Now, one downside to this, you'll see this is probably a little bit harder to understand than just going through a program in order, URL by URL, making a request and timing it like that, right? Actually visualizing how a lot of execution happens concurrently, getting all this async await syntax to be correct so that you're not blocking your program at the wrong time. And wrapping your head around that takes a while to do and can be kind of error prone and a little bit harder to read and reason about. It's actually hard to find very good explanations on how all of this works because it's kind of a hard concept to explain, and I feel like I still need to do more work on this to teach this concept a little bit better. So that's great, Larry, but what does this have to do with our stock prices? Well, we have this stock price table, if you'll remember, and we had our stock table, right, with our list of stocks. So we populated this one already because it's a relatively small table, but we want to fetch possibly millions of rows of stock price data, and we want to make many HTTP requests to Alpaca and Polygon.io, and we want to insert millions of records into our database, and we don't want to wait a million years to do so. So this table we hadn't yet populated yet, so let's go ahead and do that now. And so I'm going to use asyncpg this time instead of asyncIO, and I'm going to use the same concept of aiohttp. And instead of using Alpaca Trade API, the Python package, we're just going to make these HTTP requests to Polygon.io. We're going to give it our API key, and then we're going to just make many different requests concurrently and get the data back, minute bar data back very quickly. And I'm just going to demo what the program looks like for you. And so here we go. We're not going to write this line by line. I'm just going to post it in GitHub so that we can move on to the analytics functions. But what I have here is my asyncio.run, which just kicks off this main coroutine over here. So it's called get stocks. So we're going to run it. And what I do is use asyncpg to create a database connection pool. So there's this shared pool of database connections so that many different inserts can happen. Okay, and so the first thing I do is get a connection, and I just want to select star from stock. And so I just want to get all the stocks in the stock table. So if I jump to the stock table, you'll see we have all these stocks. But since I'm focusing on the ETF database for now, I'm just going to do the ones that are in one of our ETF holdings. So if I do select star from stock where ID is in, select holding ID from ETF holding, and I run that, you'll see that'll just limit it to the stocks that are part of one of the ARK ETF funds, right? So this is what, a couple hundred stocks, 206 stocks we're going to use, which is double the amount we did in the NASDAQ 100. And so we have these stocks that are part of the ARK holdings. And I want to fetch 5-minute bars from Polygon.io API for each of these stock symbols. So I'm going to loop through each of the stocks. And what I'm going to do is build a mapping and a dictionary from where the key is the stock ID. And the URL is just a string representing the URL that we need to fetch. And since the Alpaca API has this URL, and you can get a ticker, you need to pass it a stock symbol. You give it the time range. So I want 5-minute bars. And I'm just going to get from October 1st, 2020 through January 1st, 2021. So what's that, like 4 months? 4 months of 5-minute bars, which is thousands and thousands of minute bars, open, high, low, close data for each symbol, right? And I put limit 50,000. I think it'll limit you to like 100 at a time unless you specify a limit. So 50,000 is more than enough. There's more, that's more than the number of 5-minute bars in this time range, right? So dictionary, stock ID is the key, and the value is a URL that we need to request to get 5-minute bars for that stock ID, okay? And so then I'm going to call get prices. I'm going to give it a reference to my database connection pool and give it this dictionary of URLs. And so this time, instead of doing the get URLs where we just gather and fetch a bunch of websites, what I'm going to do is gather requests to all of these API endpoints. So I have a big list of API endpoints, so I'm doing a gather there. And so I have this gather for get price. So my get price here is the code that is used to make an HTTP request to one of these price URLs, right? So we're making an HTTP request to get one of those price URLs, right? And then we're getting the response. And then I'm building a list of parameters to pass to the database, okay? So what I'm doing is async IO gather. And so I'm queuing up a big list of calls to get price. So I'm going to call get price 200 times, but I'm going to call it get price concurrently. And then concurrently, we're going to request all these price endpoints, right? And then eventually all those are just coming back at different times. And then we're going to get this nice big list here of stock bar data. And so what I'm doing here is using a list comprehension. So for each bar I get in my HTTP response, I'm going to get the open, high, low, and close from the Polygon IO API. And I'm going to process the Unix timestamp. And so I just have a big list of database parameters, and I'm going to do an await write to DB. So I have another asynchronous coroutine, and all that does is write the price data to the database when it returns from the API. And so that's using a method, or that's using a routine called copy records to table. And so instead of just writing an insert statement, asyncpg here has a special copy records to table, and this copies a list of records to a specified table using binary copy, and this actually runs much faster. So I could use connection.execute many and just run a bunch of insert statements for each of those bars that I built, or I can use copy records to table, and this just does this big batch really quickly. So you give it the name of the table, and then this big list of bars that we have in a list of tuples, right? And so a bunch of concurrent requests, a bunch of response coming back concurrently, and then building this big list of all the different data that we need to insert, all the different bars in the giant list there. And then this is just batching a whole bunch of inserts, so it's copying all of these in batch really quickly to the database, okay? And so now if I just run that, you can see what happens. So I put populate prices, and that's going to run for a while. So you can see it's come back. It took around 45 seconds here. And so we fetched 5-minute bar data for 4 months of time for 206 stocks in 47 seconds, which is pretty good because that's actually faster than just making 100 web requests to like google.com and so forth, right? You remember that took 60 seconds? But this actually fetched for 200 stocks. It fetched these giant JSON payloads with 5-minute bar data for 4 months of data. And it did it for 200 stock symbols, and it wrote it all to a Postgres database, so inserted it all. And so now if I go to my stock price database, okay, I'm going to close that, and then if I'm going to go to my stock price, and then look at this, you can see there's price data for all of these different stock symbols in here. So you can see, and indeed, it starts at October 1st, because that's the first date I gave, and then we have a stock ID for each one, and all of that data there. And so I can just page through it, or I can go to my SQL query here. And let's just do something real quick. Let's do select count star from stock price and see how many records are in here. So you can see we have over 1.5 million records, right? And so you can see that's pretty good to make hundreds of HTTP requests and insert 1.5 million records in 45 seconds. It's pretty good, right? So let's just calculate that real quick. And so I did that already. And so you see that's over 30,000 rows per second. Yeah, so you can see we're inserting over 100,000 records every few seconds, and we're doing more than just inserting. We're having to make all these web requests as well. So you can see where Postgres is ingesting this really quickly. And I haven't really taken the time to even see if I did this all perfectly optimally or perfectly indexed the database or anything. But for most purposes, if you can insert 100,000 records in a few seconds, you're probably doing pretty well for the type of projects that we're working on. So yeah, I think that's it for this video. We have our stock price table that we're going to be working with. So this is all ready to go, and I don't have to talk about fetching the data again. We have this huge data set of millions of records, and from that point I can show you how to use continuous aggregates and how to use various time analytics functions, maybe calculate some moving averages, some price patterns, some histograms, standard deviations, some technical indicators, all those sorts of things. Let's just do a demo of the types of queries we can run on this stock price data. And you see we have 5-minute data here, 6:30, 6:35, and 6:45. Yeah, so yeah, it looks pretty good. So that's it for this video, and I'll see you this weekend. And hopefully I'll put out a few more videos that use this data. Thanks a lot for watching.